22 of section 1.5.1 asks us to find all the critical points of the given function here, h of x equals x to the fourth minus 4x squared, on the following intervals. Now, first step is we'll just find all the critical, or all the points where the derivative of h of x is equal to 0. So we compute the derivative of h, and see that using the power rule, we get 4x cubed minus 8x, and now we set this equal to 0. Now, of course, one option is x equals 0. So, right. Start a list of all of our critical points. And first one, right, x equals 0. But of course, if x is not equal to 0, then we can divide both sides by x, and we see that 4x squared minus 8 equals 0, or x squared is equal to 8 divided by 4, or 2. So x is equal to plus or minus square root 2, which is about plus or minus 1.414. So next we want to look at each interval that we're given and see which of these critical points lie in the interval, and then of course we'll need to see whether the function is differentiable on the entire interval. If there are any points where the function h is not differentiable, then those will also be critical points. So our first interval is the open interval -3, 1, and h of x is differentiable on the entire interval. You can see that by looking at the derivative and seeing that it's defined on the entire interval -3, 1. So we need to see exactly which of the critical points lie in this interval. Clearly we have x equals 0, and we do not have x equals the positive square root of 2, because our right-hand endpoint is 1. But we do have negative 1.414 contained in this interval. So it does contain x equals negative square root 2. Now, part B is the same interval, just with including the left-hand endpoint. So we have the closed interval, or the interval containing -3 to 1, but not containing 1. So again, this will contain x equals 0 and x equals minus square root 2. But the function is also not differentiable at -3, because the limit doesn't exist or the limit from the left does not exist. So we also have x equals -3 for a critical point. Now, part C, we have the closed interval -1 to 3. Again, this will contain 0. Let's see, will not contain negative square root 2, but it definitely will contain the 1.4, so it does contain this positive square root 2. And here we have 2 points for which the function is not differentiable, the left-hand endpoint and the right-hand endpoint. So x equals -1 and x equals 3 are also critical points. And finally, we have the closed interval 3, 6. And let's see, 0 is not contained in this interval. Square root of 2 is not contained in this interval, and neither is negative square root 2. So none of the points where the derivative is equal to 0 are contained in this interval, but the derivative is undefined, the function is not differentiable at either of the endpoints, again, because we have a closed interval. So x equals 3 and x equals 6 are the critical points of the function restricted to this interval.